Hello students, welcome to the video based on the topic Cauchy Convergence Criteria, which states a sequence of real number is convergent if and only if it is a Cauchy sequence. So before starting the proof of this theorem, we must know about the convergent sequence and the Cauchy sequence. So let's talk about the convergent sequence. A sequence, a sequence x is equal to xn of real numbers is is said to be converge to some x that is belong to real number if for all epsilon greater than 0 there exists a natural number, let's say k epsilon, such that mod of xn minus x less than epsilon for all n greater than equal to k epsilon. So it is the definition of convergent sequence. Now we talk about the definition of Cauchy sequence. So students, a sequence x is equal to xn is said to be Cauchy sequence if for all epsilon greater than 0 there exists a natural number, let's say h epsilon, such that mod of xn minus xm less than epsilon for all n comma n must be greater than equal to h epsilon. So it is the definition of Cauchy sequence. Now we start to prove the Cauchy convergence criteria, and it states a sequence of real number is convergent if and only if it is a Cauchy sequence. That means uh, this theorem can be divided into two parts. That means if a sequence is convergent, then it is Cauchy, and if a sequence is Cauchy, then it is convergent. So let's start with the part one. That means we have given that means we have given a convergent sequence and we prove it as Cauchy sequence. Right. So we let x is equal to xn is a sequence that is that is convergent. Right. If it is convergent, then obviously limit of the sequence xn must be some x. Obviously, x belong to some real number. So we can apply the definition of convergent sequence. Here we can apply the definition of convergent sequence. So for any epsilon greater than 0, there exists a natural number, let's say k epsilon by 2, such that mod of xn minus x mod of xn minus x must be less than epsilon by 2 for all n greater than equal to k epsilon by 2, right? Therefore, if h epsilon is equal to k epsilon by 2, and if we have numbers, natural numbers n and m, that must be greater than equal to h epsilon. So we take mod of xn minus x and we add and subtract x here, and we know if we break mod in two parts or more than two parts, then we get the inequality that is less than equal to inequality, and here we get mod of xn minus x plus mod of xm minus x, but both are strictly less than epsilon by 2 is equal to epsilon. Because epsilon is arbitrary real number, because epsilon greater than 0 is any arbitrary real number, implies x is equal to xn, that means the given sequence that is convergent is a Cauchy sequence. Now part first is complete. We begin with the part second. That means converse part. So conversely, we let we have a sequence x is equal to xn that is Cauchy, and we prove that x is a convergent sequence, and we prove that x is convergent to some real number. So for that, we first prove that the given sequence x is equal to xn is bounded, right? So first we prove that the Cauchy sequence is bounded. For that, because we know the given sequence x is equal to xn is Cauchy, it is given, right? So we take epsilon is equal to 1 and h is equal to h1 and n must be greater than equal to h. Then we have mod of xn minus xh must be less than equal to 1. So if we break the modulus, we know we get the inequality which is already here, and here we use the triangular inequality. Triangular inequality. And finally we get mod of xh must be less than equal to mod of xn, sorry, mod of xn must be less than equal to 1 plus mod of xh. So if we set m is equal to supremum of mod of x1, mod of x2 till mod of xh minus 1 and mod of xh, it follows, yeah, it implies mod of xn must be less than equal to m for all n belong to natural number. That means the all terms of the sequence must be less than m, but it is nothing but the definition of bounded sequence. So here we imply that the sequence x is equal to xn is bounded. Once the sequence is bounded, then we know by Bolzano-Weierstrass theorem. So here we can apply Bolzano-Weierstrass theorem. The statement of Bolzano-Weierstrass theorem: a bounded sequence of real number, a bounded sequence of real number has a convergent subsequence. Has a convergent subsequence. Right. So there exists a subsequence. So there exists a subsequence x dash is equal to x n k of the given sequence x a that converges to some real number, say x star. Right. So finally we complete our proof. So we complete our proof by showing that the given sequence x converges to x star. Since the sequence x is equal to xn is a Cauchy sequence, so by we can apply the definition of Cauchy sequence. That means for given epsilon greater than 0, there exists some natural number, let's say h epsilon by 2, such that if we have two natural numbers n and m, such that these both must be greater than equal to h epsilon by 2, then mod of xn minus xm must be less than epsilon by 2. So here again we use definition of Cauchy sequence. Since we have a subsequence converts to x star, so we can apply the convergence sequence definition here. For epsilon greater than 0, there exists a natural number k that is greater than h epsilon by 2 and it belongs to the set belong to the set n1, n2, n3 like this, such that mod of xk minus x star less than epsilon by 2, right? Here we use a convergent sequence definition. Since k must be greater than equal to h epsilon by 2, it follows that with m is equal to k, that means if we uh, take m and k both are equal, then xn minus xk less than epsilon by 2 for all n greater than equal to h epsilon by 2. Here it is get from 1. We have done nothing but in from 1 we replace m with k. Therefore, if n greater than equal to h epsilon by 2, we have modulus of xn minus x star. If we add and subtract xk, then we get minus xk plus xk minus x star. And we know if we break modulus in two or more than two parts, we get the less than equal to inequality. That means mod of xn minus xk plus xk minus x star. Right. Here we use triangular inequality. And we know both are strictly less than epsilon by 2. And finally we get that xn minus x star. That means finally we get xn minus x star must be less than epsilon. Since epsilon greater than 0 is any arbitrary real number, implies limit of the sequence x is equal to x star. That means sequence x is equal to xn is convergent. Hence proved. Thank you.